is Christine from WabTech, and today I have two quick experiments to share with you, and it's going to tell us a little bit about energy and what it takes to dissolve something. And before we start, I just want to say that both of the experiments today require some very hot water. So if you're going to try these at home, I ask that you have an adult who is supervising you with the hot water part of this experiment. So again, I have some hot water that I just boiled on my stove. I have some cold water that has been in my refrigerator. I have 2 clear glasses, and I have some food coloring. So for our first experiment, what we're gonna do is we're gonna take our hot water and we're gonna pour it into our glass. And then I also have some cold water that I'm gonna pour into our other glass. And they're about the same amount of water. And I'm gonna take my food coloring and I'm going to, at the same time, drop 1 drop into each. So let's just take a second and observe what is happening in our glasses. Hopefully you can see okay, but it looks like our hot water, we got the color moving around in there quite a bit. Cold water, it looks like the food coloring is kind of staying on the bottom. There's a little bit coming up into the glass, but most of it's sitting on the bottom of that glass. This one's pretty much all blue now. This one's still a lot of clear. So that's kind of interesting, and we're gonna remember what we observed here. So that's our first experiment. I'm just gonna move these over to the side, out of the way. And for our next experiment, you're gonna still need your hot water and your cold water. And I also have 2 mugs. And I have some hot chocolate. So my 2 mugs with my 2 spoons, and I have hot chocolate mix. If you have packets of hot chocolate, that also works. You just would need 1 for each cup. I just have this homemade mix here that I'm gonna use just for this experiment. And what we're gonna do is we're gonna take our hot water, and again, we're gonna pour some hot water into 1 mug. We're gonna pour our cold water into the other mug, about the same amount. And I need a little bit more. There we go. I'm gonna take a scoop, good scoop of the hot chocolate, and I'm gonna pour this into my first mug, into my cold water. Now I know that these mugs, unfortunately, I didn't have any clear mugs, but I will bring the camera over here, and what you're gonna see is, there's my hot chocolates, and this one over here with the hot water, it's already hot chocolate. It has my marshmallows floating on the top, and it's pretty much already dissolved. My cold water one over here, not looking too hot. No pun intended. I do have my marshmallows, but I also have a lot of mix floating on top as well, and it's not dissolving. It does not look very fun to eat or to drink. It's kind of clumpy. Not something that I want to try to enjoy. So we'll kind of like let it sit for a minute and see if it does anything else. This one is ready to drink, ready to go. So I think in conclusion with both our experiments here, this one is all out and this one is still not really doing much. So both of these experiments kind of teach us that things actually do dissolve faster in hot water. And this is because hot water has a higher amount of thermal energy, and that is energy in the form of heat. So the hot water actually provides that thermal energy to the molecules in our hot chocolate, and it's converted into kinetic energy, which you might have talked about in school. Kinetic energy is the energy of motion. And that allows it to move at a faster speed. The faster hot water bumping against the solute, which is the hot chocolate in this case, the quicker it will dissolve. Also, the amount of energy required to dissolve a solute into a solvent depends on what the substance actually is. So the solutes with a stronger molecular bond will require more energy for the bond to be broken. Solids with a weaker molecular bond can dissolve at a lower temperature than the strong solutes. So this actually means that our hot chocolate has a strong molecular bond and it needs more energy to break down. So this is why we use the hot chocolate, which has more energy in it. Or the hot water, I'm sorry. So, in conclusion, our hot water has more energy, more thermal energy, converting into kinetic energy, allowing our hot chocolate mix to dissolve. Cold water, no energy, no dissolving. So I hope you had fun with this experiment. I hope you learned a little bit something, and I hope you have at least one mug of hot chocolate that you can enjoy. Have a great rest of your month, and we will see you again next month. Bye.